In this video, we're going to look at the structure of atoms. A long time ago, the Greek philosopher Democritus realized that everything on Earth was made of atoms, very, very small particles. It wasn't until a long time later that the next model of the atom was proposed by Thomson, the plum pudding model. This posited that there was many electrons embedded in a sphere of positive charge like plums in a pudding. A little bit later, Bohr came up with the idea that electrons orbited around the nucleus like planets orbit around the sun. And a little bit later than that, our most current model of the atom supposes that all of the electrons are in a cloud around the nucleus and we can't really tell where they are. In the next slide, we're going to take a look inside the atom to see what parts make it up. And to do this, we're going to use Bohr's model of the atom so we can see a little bit easier the separate parts. You can see here that there are red and green particles in the center. The red are positive protons and the green are neutral neutrons. These make up the nucleus, which give the atom its mass. Around the outside are the blue-coloured electrons. They are orbiting the nucleus and they are found in shells or layers. Note that of course these colours aren't real. Take arsenic, an element on the periodic table. It has a number 33, as you can see here. This tells us that there are 33 protons in the nucleus and also 33 electrons orbiting the nucleus. One important thing about atoms is that they are neutral, and that means electrically neutral. It means they have no charge overall. So for example, looking at arsenic again, it had 33 positive protons and 33 negative electrons. Overall, there is no charge. Right now we're going to focus on electrons. Although protons and neutrons are important, chemists mostly focus on electrons because these are the particles that are involved in chemical reactions and bonding. Here is a picture of a calcium atom. You'll notice that it's got 20 electrons arranged in layers. Sometimes we call these shells. Each shell can hold a maximum number of electrons. For the level that we are studying at, this maximum is 2 in the first level, then 8 in the next, and then 2. Calcium has 20 electrons, so it has this arrangement: 2, then 8, then 8, then 2. This is the biggest one we need to know. At higher levels, you'll need to know a little bit more than this. Just a reminder that calcium has 2 outer electrons as it's in group 2 on the periodic table. Let's have a look at some examples to see what we've learned. For each of the following atoms, I want you to give me its number of protons, the group it's found in, and its electron arrangement. You can pause the video as you write down your answers. Pause the video now. Sodium, with atomic number 11, must have 11 protons. It's in group 1 and its 11 electrons are arranged 2, 8, 1. Aluminium, with atomic number 13, must have 13 protons. It's in group 13 and its electrons are arranged 2, 8, 3. And argon, with atomic number 18, has 18 protons. It's in group 18 and its electrons are arranged 2, 8, 8. Looking at why electrons are so important, it's because these are the particles that are involved in reactions. Atoms are more stable if they have a full valence or outer shell. To get this full shell, they gain, lose or share their valence electrons by reacting with other atoms. Sharing electrons is something we cover in level 2 and above. However, in year 10 and level 1, we're focusing on gaining and losing electrons. By gaining and losing electrons, atoms are transformed into what we call ions. Ions have an overall charge. We're going to look at ions more closely in the next video.